Grace and peace to you all, and welcome back to my fifth video on gamma functions. Okay, on today's video we are going to look at the second definition of a gamma function. Okay, so the second definition is called definite integral definition. Definite integral definition, so meaning we are going to use integration. Okay, so this is the second definition. It's gamma of z is equal to the integral from 0 to infinity of exponent of minus t, then t to the power z minus 1 dt. So this is the definite integral definition. So this is equation 1. So definite integral definition can be written in three forms. So we have other two forms which we need to discuss. Okay, the other form will be let t equal to, so where there is t we are going to put x squared. Let t equal to x squared. Okay, when you substitute for t, we need also to make x the subject of the formula. Okay, so to make x the subject of the formula here, what we do is we need to get rid of the squared, the power 2, and the reciprocal of squared is square root. So you introduce the square roots to both sides of the equation. So if you square root this side, okay, x square root x squared, you are going to remain with just x is equal to the square root of t. Okay, then the next step is we need to find dt, because we also need to substitute dt. When we substitute t with x squared, it means even dt should be in terms of x. Okay, so we need to find dt. So we said dt is equal to, what is the derivative of x squared? That will be 2x, then multiplied by dx. Okay, when we change the variables, even the limits must change. Okay, so our initial limits were, that is t from 0 to infinity, and this is converted to x. So x will be, so we want to know the limits for x. So when t is 0, x will be what? So this is x is equal to square root of t. So when t is 0, when you put 0 here, the square root of 0 is just 0. So when t is 0, even x will be 0. Okay, when t is infinity, when you put infinity there, it will still be infinity. So the limits will remain unchanged. Okay, so therefore you say gamma of z is equal to the integral from 0 to infinity of e to the minus, so where there is t, you put x squared, so to the minus x squared. Then we have t that will be x squared to the power z minus 1. Then where there is dt, you put 2x dx. So multiply by 2x dx. Okay, then we simplify the expressions. We are going to have gamma of z is equal to the integral from 0 to infinity. Okay, this will be as it is. So we are going to have e to the minus x squared. This will be 2z minus 2. Then we have x here, so we add a 1. Since when you have same bases, you add the powers. So it will be minus 2 plus 1, it will be minus 1. So we are going to have x to the power 2z minus 1. Then there is a 2 this side, then dx. So these 2 can come to the front. Okay, so therefore gamma of z is equal to 2 integral from 0 to infinity of e to the minus x squared, then x to the power 2z minus 1 dx. Okay, then we can write this in terms of t. So gamma of z is equal to 2 integral from 0 to infinity of e to the minus t squared, then t to the power 2z minus 1 dt. So this is the second form of definite integral definition of a gamma function. Okay, it must be 3. Let's go to the next one. Okay, so for the next one, we are going to let where there is e to the minus t, we'll put a different letter, meaning it's supposed to be just a single variable. Okay, so we start with the normal one. Gamma of z is equal to integral from 0 to infinity of e to the minus t, then t to the power z minus 1 dt. Okay, so first step, we are going to let e to the minus t equal to x. Okay, e to the minus t equal to x. Okay, so what we can do, we can bring down the minus t there, or we can just get rid of the exponent. And we know that the reciprocal of an exponent is the natural log. So we are going to introduce a natural log to both sides of the equation. So if you introduce the natural log here, it will cancel out the exponent. So it will just remain with the minus t equal to, then you introduce the natural log here, it will be natural log of x. Okay, then to remain with just t, we are going to divide the minus throughout. So when you divide the minus here, you are going to get t is equal to, when you introduce a minus here, the minus, we're going to reciprocate this x. So we are going to have natural log of 1 over x. Okay, then we can find dt, because we need also to substitute for dt. So you say dt is equal to, so how do you differentiate natural logs? Okay, so first we differentiate this, what is inside. So what is the derivative of 1 over x? Derivative of 1 over x is minus 1 over x squared. Then you divide by this same thing, that is 1 over x. Then multiply by dx. When you divide these two, this will change to multiplication. We are going to have x over 1. X will cancel 1x there. So we are going to remain with minus 1 over x. So dt is equal to minus 1 over x dx. Okay, so now we can change the limits. So you say limits. Okay, our initial limits were from 0 to infinity. So that is t from 0 to infinity. We are changing to x. So this is equal to x. The limits will be. So you substitute with a 0 where there is t. So if you put a 0 there, x will be a 1, because exponent to the power 0, it will be a 1. So we are going to have 1. If you put infinity, okay, exponent, the limit as t approaches infinity of e to the minus t is a 0. So when t is infinity, x will be a 0. Okay, so therefore gamma of z is equal to integral. So the limits have changed from 1 to 0. Then where there is a exponent of minus t, we are putting x. So we have x multiplied by, where there is a t, we put the natural log of 1 over x. Okay, so we are going to have natural log of 1 over x. Okay, this is t. That is to the power z minus 1. Then where there is dt, we are going to have a minus 1 over x dx. Okay, so this x and x will cancel out. And always remember that when you multiply an integral with a minus, the limits will change or will swap. So this minus is going to change this limit. Okay, so the minus multiplied by this, the limits will change. So gamma of z is equal to integral from 0 to 1. Okay, the x's have cancelled, so we have natural log of 1 over x into the power z minus 1 dx. Okay, and in terms of t, it will be gamma of z is equal to integral from 0 to 1 of natural log of 1 over t to the power z minus 1 dt. So this is the third form of the definite integral definition of a gamma function. So the second definition of the gamma function is in 3 forms. So you need to remember this. Gamma of z is equal to the integral from 0 to 1 of natural log of 1 over t to the power z minus 1 dt. So this is integral form. Then the other form is the gamma of z is equal to 2 integral from 0 to infinity of exponent of minus t squared, then t to the power 2z minus 1 dt. Then the last one, we have gamma of z is equal to the integral from 0 to infinity of exponent of minus t, then t to the power z minus 1 dt. So that is the definite integral definition of gamma function. Thank you so much for your time.